Good morning. Thank you for having us. So here we go. Now it's going to advance. So putting data to work. So we'll talk a little bit about our perspectives. But as mentioned up front, we'll also get into how to make this successful at the building level, right? You can show all kinds of data. You can monitor everything that's in the building, but at the end, you got to make something happen. And so we'll talk through some of the findings that we've had over time and how we see that sort of working. Just a little bit about Agilus. We sort of look at this as kind of an energy MRI for your building. We look at this from our perspective. It's how can you do something that's quick and non-invasive? Take advantage of existing equipment, existing data that's out there, because there's a lot of it. So again, the initial principle, nothing to set up or install. We're all about monitoring and metering. If you get into that, but there's an awful lot you can do right from the very beginning without any upfront cost. Instant insight, 10 to 25% annual savings. It's not hard to get to 10%. Right, on a weather-adjusted, type of day-adjusted basis. It's just amazing things you can see. The best we've done has been 40, 50, I think even 60%, but those are on the tail. Our system is a patented system, so that's also unique in this space. It's unique and proven technology. Not only do we use this directly with customers, but a lot of large HVAC and other consulting and even power supply companies will also use this as a way to engage the customer, showing them what's going on, because at the end of the day, they want to save money. And taking advantage of the data to better understand that can be very, very effective. We've done thousands of buildings using our technology on over 800 clients. Again, we have a direct and indirect business. I have no idea how many square feet, but actually we don't really care as much about square footage because our point is that we're going to compare the building to the building, okay? And you can't move, right? It's what you've got there. Let's focus on that. And you'll understand that a little bit more when I show some buildings that have won some great awards that aren't run very well at all. The types of buildings, again, office, loads of office, retail, lower, higher ed, healthcare, municipal buildings from dog pounds to prisons to the whole range. We've done ships tied to the pier, ice rinks. Not that we knew how to run a mushroom farm, but it was interesting to see what was going on and give the feedback to the guy that was running the facility of things that really, is that what needs to happen? I understand humidity is a part of this, right, to be able to get them to grow, but you never know. We also received data from one utility, talking about the religious part here, one of the churches or synagogues, from a broker down in Texas, and they told us it was a synagogue, and we're looking at it thinking, okay, so what's happening at 8 a.m. it drops down, noon it drops down, 3 o'clock in the afternoon it drops down. This looks like a manufacturing facility. Well, sure enough, the utility had sent the wrong data. So you look at enough of these things, you start to get an idea of what the patterns can actually be. So some basic perspectives here on this, right? So this is, I think, also complements Kevin and Sean's perspectives and where they're coming from as well. This is still the way most of energy services are done, right? Look at the bills. Or we don't even look at the bills. So what's your problems? What are the issues? And so somebody coming in, a vendor coming in, is not really going to understand how your building's actually operating. If they look at the bills, actually that's a good sign. But this is a simple enough example, can't be any more boring than that of sort of the traditional approach. We take this same building, this building not far from here, and put it into our system. It looks like this. So the traditional approach, assuming they're looking at all the bills, is looking at 12 points a year. Does anyone know, other than Sean, how many 15-minute periods are in a year? 35,040, if it's not a leap year, okay? So, little caveat. But the point being is you're almost 3,000 times as much data, assuming you just have 1 meter, right? Because we have weather data, so 15-minute other things that are in there. You're going from 12 to almost 3,000 times as much. This is what it looks like if you just look at the bills. This is what it looks like when you take advantage of that data, right? And this one actually had 2 meters, so I'm not even counting the fact that we've got over 70,000 points. I'm just saying, let's just say we had 1. But the point also that this is in Pepco's area, they had put 2 meters on the building. And we'll talk about where meters and data are across the country. We get out to California, we did a hotel that Southern California Edison had 35 meters on it. And the smallest of those meters was at a peak KW low of half a KW. Okay, we don't care as much about half a KW, right? But getting to the particular point, the more and more the utilities are putting out more meters, looking at more things within the building. We still run into the multi-megawatt hospital that's got 1 meter on it. There's a lot going on in a hospital to look at with 1 meter, but that's before we start to get into the control system data, which I'll explain. So hopefully you'll get some perspectives on that. Now, this is one, again, a little bit hard to see on there, but if you look in the top left corner, we were working with a defense contractor here at a project, and they had a little 60 kW building. Now, 60 kW is about half a McDonald's size, to put it in perspective. It's up in the upper Midwest. and they had their own meter on the building, and they were collecting the data on a minute-by-minute basis. So if you see the blue line over there, and this is just one weekday, right? And these you'll know from looking at Sean's information of what a decent profile. The basic profile doesn't look too bad. Pretty strong shutdown, strongly, the startup's not so bad. But you start to look at the minute by minute, and you'll see some dips that are occurring very early on. Okay, that's odd. It should really kind of blend right up in the day. A lot of load cycling there in the afternoon. Again, not a very big building. Maybe the rooftop unit's got single-speed drives, so maybe it doesn't make a lot of sense to change that. And some weird thing happened about 8 o'clock in the evening. Same day, same area of the curve, right, to the right, is taking that and aggregating on a 15-minute basis. So when we're trying to find things in a building, you can get down to looking at it 30 seconds. Where are we going to see the problems and the issues? And on this one, if you can see it on there, you can still see those. Well, the amplitude's not as great. There's a lot more 15-minute data that's out there because that's how the utilities, generally speaking, other than Virginia where it's 30 minutes, are setting their demand charges. So there's plenty of it out there. But we can still see the problems at 15 minutes. 30 minutes is like what we see kind of PJM area where we'll frequently get that. Still see them. But in this example, by the time you get to 60 minutes, you can't see it. So we go and talk to a potential client, and they don't even know what interval data is. And they may or may not be looking at the bills. They don't really know what they're missing. And there's so much more that you can kind of see behind that. So we'll still take hourly data, and this is what we often get from New Jersey, but we prefer at least to get down to the 15-minute basis. Okay, so here will be a little bit of a heretic, right? This is a LEED Gold Energy Star 95 building in Northern Virginia. It's lower school. So I haven't orientated you to the 3D. Again, our systems are all dynamic. This is just static here. Time goes up to the right. Dates move up and to the left. The vertical dimension is demand. It's a 95, right? I mean, there's only 5% of buildings in that area that would actually be better. Somebody spent a lot of money to put real systems in, assuming that they went through the process in the correct way. We see load cycling. We see early morning overconditioning. Now, we've been certain jurisdictions where they'll say, hey, we've got to bring it on early because I'm trying to avoid that peak in the afternoon. This was in Virginia, so that can make sense. But we often find that they're just not that familiar with the intricacies associated with the tariffs. And there's a lot more that goes into it. So here we have a 95 building. An energy company brought this to us, engineering, and they were just going to pass. I mean, come on, it's LEED Gold, it's 95, right? There's nothing we can do. This is about as bad as it gets. Right, so remember Sean talking about what's happening overnight, getting to the simple things aspect of where it can kind of get down to. You've got startups that are occurring all different times in the morning. There's nobody there. Okay, same that it doesn't shut down in the evening. They may have after care, may need to go a little bit later, but it's not a high school, right? They don't have basketball games running till 10, 11 o'clock at night. And they've also got equipment, so presumably they've got a decent control system, but they've got large load cycling taking place as well. So what this building should actually look like is it should look like that. We've done about 600, 700 schools in California. This is what a California school looks like. Right? California is very expensive when it comes to demand and energy charges in the afternoon. Can be 2 to 3 times what they are in the morning. Synthetically pre-cooling your building, right? Synthetic thermal storage system can make a lot of sense to get it down, particularly if you've got lower school and people are leaving, but you can make buildings run this way. What's important that all of us have said here is it's not so much about, oh, we're going to make it 2 degrees warmer or 2 degrees colder in the different seasons. We're paying attention to the unoccupied areas as a starting point. A lot less resistance there. Let's get the building tightened and tuned up first before we start marching down that particular path. But for a 168-hour week, for an office building, about half of that week is typically, or could typically be in unoccupied mode. That's a lot to go after before you start working about what you can do middle of the day. And also, if they go through this particular process and the building's not running very well, they can kind of take those savings and find ways to invest in lighting upgrades and other types of things to increase the enterprise value of the building, but always start in the proverbial low-hanging fruit, but get the building running the way it can be running, right? And then you're also getting the support of the building team, which is critical, and I'll explain that. We just don't stop at energy data, right? There's a whole lot of additional information that's out there on many control systems that buildings and owners have spent money on that aren't really being used. We had a high school in Milwaukee that sent us 30 million records out of their trending system, their BAS. Nobody's looking at that. A good portion of those actually don't change at all, meaning they serve no purpose actually in the control of the building. So we actually now sort of move into, if you got a BAS system that can trend, turn it on, right? Trend everything, and we'll come back, we'll figure out what's there, what's working, what has a standard deviation of 0. Now maybe if it's a set point over 3 weeks, Okay, fine, right? 72, whatever it might be. But if we've got critical components that don't change, then somebody spent money on a system that's serving them no real value, or not the value that they expected. So this is a case of, in fact, this one was a Northern California building, brought in 132 data streams, cleaned it. Data's always dirty. Got to clean it, remove the duplicates, match it all up, interpolate it, on and on. But this is one we could see that wasn't economizing very well in a market that should be able to economize in a great way, Northern California. So what happened? We sort of looked at this. We got the control system data, hot water and chill water valves open 100% at the same time. Didn't have to connect anything. This data was already there, just nobody had the time or effort or understanding of what to do with it. So it can be very powerful if it's there. This one's a little bit hard to see on this, but this is a Denver building. And if you'll notice, since you're now experts on looking at the 3D part, it's got this ridge that runs at 3 o'clock in the afternoon for an hour. It's outside air temperature sensor. Is outside air temperature sensor in a building control system important? Yes, no? Generally, okay? We're going to tap into that one way or the other, right? We may look at enthalpy, we may look at other, humidity and other sort of features. It's moderately important. Okay, so what might be happening at 3 o'clock in the afternoon that caused the OAT to go up 10, 15, 20 degrees for an hour or so? Sun? Could have a kitchen exhaust that's some localized problem. All right, well, if you notice on the right, so we talked to these guys about it. Again, great control system. They just don't have the time. And we'll talk about how to get this to work and motivate the different groups here, bring them all together. This isn't killing their building. But we had the guys go up to the roof, 3 o'clock in the afternoon, and take some pictures. Now, there is a sun shield on that sensor on that wall over there. The problem is the way the wall's orientated, that as the sun comes around, shoots it up every day. So this is a smaller point, but it's amazing what you can see. We see an equipment that's never connected in the control system, and it's been that way for years. We've seen buildings that were never properly commissioned, and 1, 2 years later, they're just running in a horrible fashion that nobody had any idea. So data, it really is your friend, the superpower, as was said. So some of the stuff we're going to start off really, really basic, and it's like, okay, I already know this. Okay, fine. What else can you tell me? But let's start from a foundation and explain some of the challenges and so forth that we've dealt with in actually making action happen at the building. So real, very, very simple here, right? Who are the main tenants we're talking about a commercial building? Well, we got the tenant. It can be a multi-tenant building. We got the property manager, we've got the owner, and we got the building engineer. Of course, property manager, building engineer, well, it's a third party, or it's the owner or an operator manager, maybe from the same company, or generally be the same company, but could all be the same company when it comes to the owner. So let's kind of talk through this. So in doing this, I mean, we've done thousands of buildings, and again, we're working directly with the company. The way that we get another building is we prove that we can actually have them achieve results. But we don't touch anything in the building. So for us to convince the building engineer, property manager to do something, one is they got to see it's not going to cause more work or problems for them. The tenants are yelling and screaming now. We got to get them on our side. And for them to really get the credit also that if we're able to achieve something, because there's a lot of knowledge there. So we went back to a very large global investment fund manager, right, advisor, pension fund advisor. We also talked to a very large third-party property management group, right, a global one, and also very well-run, smaller, local owner developer that was here too. Now, we knew a lot of these answers, but want to get it sort of directly. So if an owner shows up unannounced at a building, let's say we've got a third property management team, what are the 3 things that property manager better sit down and start to go through? Well, you better show me the leasing status. Right? I want to see what's going on with the rent rolls. How are things rolling off? Any particular problems with the tenants, right? Second thing I want to know is NOI, net operating income, right? No surprise. How's my investment doing? Have we had, operating costs that have developed unexpectedly? And what's going on with capital project? Anything we can put off, right? I want to put less cash into this building than I can. Let's move this stuff off as far as what's going on here. But if that property manager doesn't sit down and talk with this, the minute that person shows up, there could be issues. Right, now what you've got here is, so we did a little bit of data analysis went to monster.com and pulled the, unscientific, right, but pulled 15 or so job listings for property manager and for building engineer. So if everybody knows how the word cloud things work, we remove all the stop words, the ands and does and ors and whatever from this. The larger the font, okay, in a histogram, so the more frequent it's mentioned, right? So we'll presume that the hirers are looking at this saying, what's really most important? No surprise. What's the big word that jumps out there on the property manager side? Tenant, okay? Well, that's kind of what they're hired to manage. What are the other things we see on there? Maintenance, lease, budget, reports. Well, you don't want to be hitting a property management team in the middle of budget season, okay? They don't want to talk to you, right? It's pulling hair out, all the rest of these kinds of things. And then a lot of other words that kind of go into this, operations and service. We go to the building engineer side, maintenance, systems, operations, HVAC, electrical, and kind of on from there. Now, can't see the small words on there. Across these 30 or so listings that we saw, that we pulled out from there, energy was only mentioned once. And it was mentioned in the context that we want a high energy property management team. Energy doesn't even come up on this. Now, does it fit into operations? Absolutely, right? And does it fit into budget? Sure. But these are some very specific skills to understand what's going on at the building. How do you think about, are you in a regulated market like DC or like Virginia, where you got to be concerned more with the peak demand than you can with the energy, because energy is really cheap when you throw even when you throw the fuel charge? Or do we need to worry about peak load contribution, PJM? Or are we in Texas and we've got the 4 coincident peaks? Or other circumstances or characteristics in other markets. So there's a lot to take in. In the meantime, we got tenants, we got maintenance, and even interesting to see maintenance falls into both categories here of job listings. So let's think about these priorities. And we're going to get to the aha here in a second of how to be able to make this happen. But if that owner shows up and the place doesn't look good, we got problem number one. Right? I want to know what the leasing strategy is. You told me when we hired you that you were going to go from 60% to 85% in this particular time. Where are you at? What property management groups tell us the quickest way to get fired is don't have a good leasing strategy. Okay? Property looks like crap. You're going to be hearing about it. Budgets, we're going to update us. Where do we stand? If you're going to get something done by a certain time, you better have it done. Another reason that somebody can get replaced. Operations, and then depending upon the nature of the company, there could be real policies and procedures they might go through. Building engineer side, what is a building engineer to do? The building engineer is there to fix problems. That person is motivated to fix problems. They're not included in the overall discussion with the owners, what's going on. They feel isolated. They're not included. They get less likely to be out there fixing the problems and being as proactive as they can. But that's what they're there for. And if we go back to the job listings, you see the kind of capabilities and skills that they're required to have. Tenant response, right? Somebody's got a problem on the 4th floor. They always have a problem on the 4th floor. You got to jump, right? But that's always a problem on the 4th floor. Preventative maintenance, right? Let's make sure things are moving and so on. So how does this work successfully? Now, a little bit of this is kind of like, oh, well, okay, fine, we could come up with that list. But you got to have a proactive leasing strategy. Okay, we're not talking about energy just yet. But again, what does the owner want? What's going to motivate? What are the incentives associated with the team there? Because this is where it's going to turn into, well, why does the energy efficiency even matter? Got to be proactive. Got to work together to solve problems. Okay, that sounds so obvious and easy, but the best way to not make things happen at the building and to have it poorly run is that these groups don't talk to each other, and that's more common than you might think. They've got to share credit in this when it comes to the owner, even if it's a pat on the back, and they've got to have resources to do their job well. All the things you've heard about today in tools and systems get to resources. As a building engineer, you want me to do my job, you don't give me the tools, you don't give me the time, you don't tell me everything that's going on. Hey, it's for something, I'm out of here, right? So you got to give them the tools and resources to do their job. And you also saw that, well, you saw back with the job listings, what we really require of this group. So where does energy efficiency even come into this? It's not identified as a key skill in the job postings. It's not the highest priority topic for the owner. There are a limited number of hours in the day. How much more do you want me to do? Am I getting further compensated or a bonus based on how much I save at the building or more recognition? Which gets to, of course, the appropriate incentives. So the more efficient buildings that we've seen, that we've worked with, and the value of improved building energy efficiency is enhanced NOI, right? So we're able to reduce our operating cost, and you've heard low cost, no cost. There's so much that you can do before you start plowing millions of dollars into a building is to go get the building tuned up as much as it can be. In fact, it's even more important from a capital engineering standpoint because if that engineering group or vendor shows up and they haven't looked at the data, not the monthly data, they really don't know what's going on. You want to buy a new chiller? Love to sell you a new chiller, fine. Okay, but there's so much more that can be done along the way that helps on the operating expense side, but even on the prioritization of capital projects, which gets to the second point. I'm jumping ahead of myself. Ensure best application of dollars for capital improvements, boost building value, right, depending on where the cap rates are. And this could add $500,000, it could add a couple $1 million to the overall value, even on some of the smaller things of getting the building to run better. And attracting high quality tenants. This is kind of moving from, hey, it was a good idea to do, we're concerned about the environment, yeah, we just think it's the right thing to do, to really, We have to do this. And that's just not me setting up in the audience here that could likely agree with that. But we went back to the pension fund advisor and say, well, where are the requirements coming from them? Putting beyond the side that they want to do something for the environment, we have to. So our group has these particular standards, right, of environmental, sustainability, and governance that we have to do. And we have investors in our fund, and they require it as well. So it's not that they can go in there and say, well, let's do whatever we want. They actually have to report this. So for that property management team of the property manager and the building engineer, that you didn't see anything mentioned energy in their job, in the job listings, the skills that were on there, you get the high quality tenants, the Class A buildings, these investors, these owners, and they require it. And that's happening more and more going forward, and it's not a luxury for them. And that's also happening, not just from the tenants, as I mentioned. Well, this is interesting on the tenants. So I live down in Raleigh. It's not a DC market, it's not a New York market. And I was talking to somebody that had been at one of the largest third-party property managers. And they said their tenants are forcing them to write it into the lease, that you will have Energy Star and that you will maintain Energy Star on a going forward basis. So if you as a property management team are like, we don't really need to worry about this, we don't really sort of care, it's moving to the point where you better start to care. But what about the tools and resources that we have for that team that's there? How can they better do that job? Because now we're putting more things on them, requiring them to do more things, and we may not have given them the ability to do that. But it does make good business sense. Sean talked about the kind of savings that you could see. Those are very real. And no doubt they're taking that and adjusting it by weather and type of day and other features, and they're being very transparent about it, as really anybody in this industry should be doing, is really showing you there's no black box part of it. I'm going to show you where you were before. I'm going to show you where you are now. We want you to believe, because we want the incentive just like they do. Hey, you give us one building out of the portfolio. Well, we want all of them. Well, how do you get there? Well, you got to earn it along the way. You got to show that you can work with a team. Another key, well, we'll get this. So it's really, as I mentioned, moving from kind of nice to have to must have. And of course, then, there's also utility rebates. How many of you here from different buildings that have already gone to LED tubes? Anybody? Yep. Okay, different parts of the country, they don't even talk about standard LEDs anymore. It's all LED tubes, right? Moving down. Well, gee, wow, we put this investment in before, put in these great new LEDs, now we're replacing them. I thought you told me it's going to last for 15, 20 years. We have something even better, right? Now, I don't know if there's going to be something better beyond that, but that's sort of the nature of where things go. It's because, and the reason why the utilities are doing this is really not out of the goodness of their hearts, right? They've got to go back to the regulators to get a rate increase. Let's get more out of the system that we possibly can, and without having to go back and increase the cost to the individual ratepayers. And it also can obviously ensure a better return on investment when it comes to larger capital projects. So what are really the keys to this, successfully implementing an energy efficiency program? One is it's got to be a priority for the owner and asset manager. If they don't care about it, nothing's going to happen. And we've been, if we get on working with direct customer and it's just the building engineer on there, we're not going anywhere. If it's just the property manager who doesn't know what's going on in the building, it's not going anywhere. So the incentive and the prioritization has got to come from that level, or it's not really going to happen. Other success factor defined programs, again, we're seeing this written more in the policies and procedures, the asset manager's manual that one particular company has, standards of sustainability, again, thinking about the different stakeholders here, and then the ESG, as we've talked about before. They've got to have the proper tools and systems. So whatever it is that you're using along the way, you've got to get the people the tools there to be able to see and understand where in the past they haven't had that. And there's an awful lot you can do with existing systems that you already have in your building, while thinking we need to make a huge capital investment of all this monitoring. Monitoring's great. Monitoring more things is always better, but look to see what you've got to begin with, which also taps into really just the knowledge. I can't emphasize enough how much knowledge is in the heads of the people that work at the buildings. So the companies have taken approaches out there. We'll monitor the building. We'll shoot out ECMs. That's all we need to do. We actually want to tap into that bio-knowledge base that's in the head of the people that are working there. And together you put a facility action plan. They buy in, more things are going to happen. It's going to become more sustainable in the sense it's going to go beyond year one as you move your way down. Teamwork is critically important. They've got to work together, and we've got to share credits and rewards. So how we get to that next building is by making sure that property management team and the owners are able to see that it's the team there that did the work. As we showed to our system, we're the enabler. We're the coaching group to help them get to that point. And showing this a simple example over on the right, this is a building we just recently did. You can see in time, the dates go from the bottom to the top. This is what it looked like before. And on this simple one, and this isn't that uncommon, On a weather-adjusted basis, weekdays were down 17%, Saturdays were down 27%, and Sundays were down 53%. Okay, it's really helping make the invisible visible and using that as a starting point by which to get to real actions and be able to measure those. That's all I have. Thank you very much.